Lesson 11, Talking with the Server. In this lesson, you'll learn how to use the properties and methods of the XML HTTP request object to allow the object to send requests to and receive data from the server. The topics we will cover in Lesson 11 are sending the server request, monitoring server status, and the callback function. Using our knowledge of the XML HTTP request object, let's consider how to create and send server requests and what messages we might expect to receive back from the server. We're going to jump right in and discuss how to create an XML HTTP request object called myRequest. We'll then write a JavaScript function called callAjax to send an asynchronous request to the server using that object. Afterward, we'll break down the code line by line to see what it's doing. This list shows our prototype function to prepare and send an AJAX request using this object. First, we need to create an instance of an XML HTTP request object and call it myRequest. Next, we'll look at the function callAjax. The first line simply declares a variable and assigns a value to it. This is the piece of data that our function intends to send to the server as the value of a variable called surname that is required by our server-side script. In reality, of course, the value of such data would usually be obtained dynamically by handling a page event, such as a mouse click or a keyboard entry, but for now this will serve as a simple example. The server request we intend to make is a GET request, so we must construct a suitable target URL having our parameter and value pairs suitably coded on the end. The next line carries this out. We will use the open method to prepare our server request. This line specifies that we are preparing a GET request and passes it to the destination URL complete with the appended content of the GET request. The third parameter, true, indicates that we want our request to be handled asynchronously. In this case, it could have been omitted because the default value of true is assumed in such cases. However, it does no harm to include it for clarity. Next, we need to tell our XML HTTP request object, myRequest, what it should do with the progress reports it will receive from the server. The XML HTTP request object has a property onReadyStateChange that contains information about what JavaScript function should be called whenever the server status changes, and in the next line we assign the function responseAjax to do this job. We will learn how to write this function later in the lesson. All browsers maintain a so-called cache of visited web pages, a local record of page content stored on the hard disk of the browser's computer. When you request a particular web page, the browser first tries to load the page from its cache rather than submitting a new HTTP request. Although this can sometimes be advantageous in terms of page load times, it creates a difficulty when trying to write AJAX applications. AJAX is all about talking to the server, not reloading information from cache. So when you make an asynchronous request to the server, a new HTTP request must be generated every time. It is possible to add HTTP headers to the data returned by server-side routines intended to tell the browser not to cache a particular page. Examples include: unfortunately, such strategies vary widely in their effectiveness. Different browsers have different cache handling strategies and support different header declarations, making it difficult to ensure that pages are not cached. A commonly used trick to work around this problem involves the adding of a parameter with a random and meaningless value to the request data. In the case of a GET request, this necessitates adding a further parameter and value pair to the end of the URL. If the random part of the URL is different each time, this effectively fools the browser into believing that it is to send the asynchronous request to an address not previously visited. This results in a new HTTP request being sent on every occasion. Let's see how to achieve this. In JavaScript, you can generate random numbers using the math.random method of the native math object. This example contains a couple of changes to our callAjax function. We can see from this example that the script will now generate a destination URL for our AJAX request that looks something like this, where XXXX will be some random number, thereby preventing the page from being returned from cache and forcing a new HTTP request to be sent to the server. The XML HTTP request object contains mechanisms by which we can stay informed of the progress of our AJAX request and determine when the information returned by the server is ready to use in our application. Let's now take a look at the relevant properties. The ready state property of the XML HTTP request object gives you information from the server about the current state of a request you have made. This property is monitored by the onReadyState change property, and changes in the value of readyState cause onReadyState change to become true and therefore cause the appropriate function to be executed. ReadyState can take these values. When a server request is first made, the value of ReadyState is set to 0, meaning uninitialized. As the server request progresses, data begins to be loaded by the server into the XML HTTP request object, and the value of the ReadyState property changes accordingly, moving to 1 and then 2. An object ReadyState value of 3, interactive, indicates that the object is sufficiently progressed so that certain interactivity with it is possible, though the process is not yet fully complete. When the server request has completed fully and the object is available for further processing, the value of ReadyState changes finally to 4. In most practical cases, you should look for the ReadyState property to achieve a value of 4, at which point you can be assured that the server has finished its task and the XML HTTP request object is ready for use. In addition to the ReadyState property, you have a further means to check that an asynchronous request has executed correctly, the HTTP server response status code. We'll see how to test for this as we further develop our callback function. By now, then, you have learned how to create an instance of an XML HTTP request object, declare the identity of a callback function, and prepare and send an asynchronous server request. You also know which property tells you when the server response is available for use. Let's look at our callback function, response AJAX. First, notice that this function is called every time there is a change in the value of the onReadyState change property. Usually then, when this function is called, it is required to do absolutely nothing because the value of the ReadyState property has not yet reached 4, and we therefore know that the server request has not completed its processing. We can achieve this simply by using a JavaScript if statement. In addition to checking that the server request has completed, we also want to check the HTTP response status code to ensure that it is equal to 200, indicating a successful response to our asynchronous HTTP request. We can see that our XML HTTP request object, myRequest, has two properties that report the HTTP status, response. These are myRequest.status, which contains the status response code, and myRequest.statusText, containing the reason phrase. We can employ these properties by using a further loop. This code introduces an else clause into our if statement. Any server status response other than 200 causes the contents of this else clause to be executed, opening an alert dialog containing the text of the reason phrase returned from the server. So how do we go about calling our callAjax callback function from our HTML page? Let's see an example. Here's the code for a simplified form in an HTML page. We'll launch the function using the onBlur event handler of a text input field in a form. The onBlur event handler is activated when the user leaves the field in question. In this case, when the user leaves the field, callAjax will be executed, creating an instance of the XML HTTP request object and making an asynchronous server request to this file. That doesn't sound very useful. However, what if we were now to make a slight change to the code of callAjax? Now we can see that as the user leaves the form field myname, the value she had typed into that field would be passed to the server using our asynchronous request. Such a call may, for example, check a database to verify the existence of the named person, and if so, return information to populate other fields on the form. The result, so far as the user is concerned, is that she sees the remaining fields magically populated with data before submitting or even completing the form. This lesson looked at the ways in which our XML HTTP request object can communicate with the server, including sending asynchronous requests, monitoring the server status, and executing a callback function. You can now test your knowledge in the quiz area, access the scripts we learned in the lab, or go through the lesson again. The choice is yours. Thank you for choosing Sam's Teach Yourself.